Okay, this is the chemistry's Q1 Week 2 summary. Jeff Bostic here. This week in class we covered a couple of different things. Starting with the metric system, we talked about the different prefixes and the conversions that you can do in the metric system. We used a mnemonic device. King Henry died unexpectedly drinking chocolate milk to kind of help you remember the order of the prefixes: kilo, hecto, deca, the unit, deci, centi, and milli. And then we did some practice of moving the dot, the moving the dot method, where we started counting jumps and we were counting left or right, and we do the same thing. We jump the decimal point, however many jumps it took in the direction that we were moving, left or right. But then we stressed that every time that we jump that decimal, it's the same as multiplying by 10 or dividing by 10. And then for chemistry, we also talked a little bit about there's something beyond milli. We talked about micro and nano and how micro's symbol is a Greek letter. It looks like a U with a tail on the front. We also talked about how we can classify matter. Chemistry is the study of matter and how we interact with it. So we started with, how do you classify it? We lumped everything up into either one of two categories. Either you're a pure substance or you're a mixture. If you're a pure substance, you're an element or a compound. If you're a mixture, you are either a homogeneous mixture or a heterogeneous mixture. And you can read on the screen some of the different examples of heterogeneous and homogeneous mixtures. In general, solutions tend to be homogeneous. Suspensions tend to be heterogeneous. We talked about physical properties and chemical properties. Everything, all matter, can be classified according to the properties that they have. And those properties fall into either physical or chemical. When you test a physical property, you will always have the same material, the same composition when you're done testing that property than when you started. It might be a different form or phase. For instance, if you test the melting point of water, you'll start with ice and you'll start heating it up to a certain temperature, and at a certain temperature it will start to melt. Well, guess what? Before it melted, it was ice, H2O, water, and after it melted, it is water, H2O. So water before, water after, and you now know that the melting point is 0 degrees C. Congratulations, you just tested a physical property. Another type of property is a chemical property, and when you test a chemical property, you generally do not end up with the same material as what you started with. If you take water and you pass some electricity through it with like some cathodes and anodes, you can literally break the bonds that's holding the hydrogen atoms to the oxygen atom in water and get hydrogen gas and oxygen gas. Well, that's a chemical property. It's a chemical change too. And speaking of changes, we crumpled up a piece of paper in class and we burnt a piece of paper in class. One of those demonstrated a physical property and a physical change, and the other represented a chemical change. After a physical change, you still have the same material. Melting of the water, melting point is the physical property, but the water going from ice to liquid water is the physical change. There are some very distinct clues that you get when you have a chemical change, but you have to be careful because sometimes everything might not be as it seems. The signs that we talk about when there's a chemical change is, hey, sometimes it changes color, sometimes a gas comes off. In my milk and lemon juice example, you got to see a precipitate being formed. And with any sort of chemical change, there almost always is some sort of change in energy. Or sometimes it's light, but sometimes it gets hot, and sometimes it gets cold. The last thing that we talked about when it came to like these different mixtures, homogeneous and heterogeneous, is that we can always use physical means to separate these mixtures back into the pure substances that are in there. And two specific types that we talked about was distillation and filtration. Just a quick note, distillation, when you separate something using a distillation apparatus, you're separating things based on boiling point. And filtration, we just pour something through a filter paper or a coffee filter, and the solid material stays behind, the liquid portion goes through. Well, you're separating things based on particle size, right? The water molecule is super small, and it goes right through the holes in a filter, whereas either grains of sand or coffee or whatever you're filtering out, it's too big to go through your filter, so it stays behind, and that's a separation. Last thing that we talked about in one of my two classes, hopefully my first class is viewing this, is talking about something called significant figures. We call them sig figs. Sig figs are always have to do with measurements, because measurements use tools to do that measurement, right, to come up with that measurement, whether it's a scale or a tape measure or a meter stick or a volumetric flask. Each measurement that you take relies on some instrument, and each instrument has a certain amount of precision associated with it. You can see my time example right here. We can measure time with the clock on our computer, but we can measure time better with a wristwatch that has a second hand, and we can measure time even better still with a stopwatch on our phone, right? One doesn't give us seconds at all. One gives us seconds, and one gives us milliseconds. So when you write these measurements of time down, you will see more digits when you measure time using a stopwatch compared to a wristwatch with a second hand. And that wristwatch with a second hand will give you more digits when you measure your time compared to just the clock on your computer. You're just limited to minutes on the clock on your computer. Okay. When we're talking about these measurements, and doing math with these measurements, we need to be able to count in these measurements how many of the digits in our measurements are significant. And here's some rules. Non-zero digits, always significant. A measurement that has any non-zero digits in it, they're always counted as significant. So 1.956 grams has 4 sig figs. Okay, that just leaves zeros now. Since all non-zero digits count as significant, that just means that the zeros are there to confuse us and mess us up. There's 3 places that zeros can be in a number. They can be at the beginning on the left, they can be in the middle in between non-zero digits, and then they can be on the end. And the rules are different depending on which type of zeros you're talking about. Leading zeros never count, embedded zeros always count, and trailing zeros only count when there's a decimal present. So you can see in the examples, I have made all of the zeros that are significant, I've made them bold. So in this first measurement, 0.001956, those 3 leading zeros don't count. And the second 1.9006, those 2 middle embedded zeros, they always count. And then finally, the trailing zeros at the end, they will only count if there's a decimal place present, or if there's a decimal present. Okay, and then just here's a few examples to show you what I mean. And they contain different combinations of embedded and leading and trailing zeros. Here's probably the best one right here. It has leading zeros, it has an embedded zero, and it has a trailing zero. We got a decimal point present. So, ready? Here are your 5 significant digits in this measurement. So if you get that, that is awesome. Probably the toughest, like, you know how like tests have like a last question that's generally pretty tough. This is typically a pretty tough question where the question will say, write this number with 3 significant figures. You're like, okay, well the number is 4,800. So if I put a decimal point there, oh no, that makes both of those ending zeros significant, so that's 4. So then people will try to do this. They'll put a decimal point here and leave it. Well, the number's not 4,800 anymore, right? It's 480. Or they'll do that. Or they'll do that. And all of those are not legit ways to express this number with 3 sig figs. you have to have the measurement still be 4,800. So the only way to do that is you are forced to go into scientific notation. Ready? Here's my original number, 4,800. Here's my number written in scientific notation, but notice it has 4 sig figs. Finally, to get to 3 sig figs, I will have to truncate that 0 in there. That number is still 4,800, right? It's 4.80 times 10 3 times. That works out to be 4,800, but only 3 sig figs. Well, that's how you do it. If you have any questions, as always, shoot me an email. Have a great weekend.